We are going to learn a concept called as error detection and correction. Error detection and correction using cyclic redundancy check. Now, what is the advantage of it? This is a very popular method, and this method is used in our daily life in the networks, and this is also a very powerful method. Why I am telling that is very powerful method? Because this method can detect all odd number of errors, single bit errors. It can detect and correct the errors, and it can detect the errors, and also it can detect the burst errors to the highest degree of the polynomial being considered for creating this cyclic redundancy check. Now you may ask me question, how do we do this? So how do we do this? Because let us take a message. Now I am taking a message like 101011. Okay, we'll take 101010. It will be easy. 10102 times 2 3 4 5 times. You will take 1. This is a message word, and I want to use a cyclic redundancy here. So what I do is I will take a polynomial. So what is a polynomial? Polynomial is a function, is an equation, is an expression having having higher orders. Now this polynomial should be divided by x. Now if I take a polynomial like x power 4 plus x cube plus 1, this is one polynomial. The highest order of this polynomial is 4, and if we use this polynomial to create a cyclic redundancy check for this message, then it can detect all odd number of errors, all single bit errors, and also it can detect a burst errors, so up to the highest degree, that is 4 bits. So it can detect up to 4 bits of burst errors. So that is why this method is called as a very powerful method. Now what we do here, usually whenever we send a message, we will not send a simple message, we will add some more bits. Why do we add extra bits called as redundant bits? Redundant bits because we cannot detect and correct the errors in a given message. So what we do to detect and correct these errors, we will add some more number of bits which will help us to detect our errors, which are called as redundant bits. Now what we do here, how many, now the question is how many redundant bits you are going to add. Now how many redundant bits I am going to add is, let us suppose for example I am given a polynomial x power 4 plus x power 3 plus 1. I have given a polynomial like this. So the question is how many redundant bits you are going to add. So for that, what I will do is, now this polynomial now will be acting as a divisor, and this message will be acting as a dividend. I will divide this message with this divisor, that is a polynomial. How do I divide like this? Because we will expand this polynomial as 1 into 10 power 4 plus 1 into 10 power 3 plus 0 into 10 square plus 0 into 1 into x power 4 plus 1 into x cube plus 0 into x square plus 0 into x plus 1 into x power 0. Now let us take all the coefficients over here. Now what are the coefficients? Are 1 1 0 0 1. What will get the message? What will call all the coefficients you have? Binary coefficients, 1 numbers you have 1 1 0 0 1. Now this will become your divisor. Now how many redundant bits you will add means 1 minus the number of divisor bits. So how many you have here? 5. 1 minus that you have 4. That means to send a message of 10 10 bits using a polynomial x power 4 plus x cube plus 1, I have to add 4 extra bits. So when I add 4 extra bits, my message will become 10 10 10. Then 4 extra bits is, I am adding now zeros first because I don't know which bits to be added. So I have to find out what redundant bits I have to add. So to find out them, first of all I am replacing them with zeros, 1, 2, 3 and 4. Now we will take this and I start dividing this with my polynomial divisor polynomial, that is your, which is in the binary form, that is your 1 1 0 0 1. Now I divide it, now dividing 1 1 0 0 1. Now how do you divide this? You use by doing a binary division. So binary division means your XOR operation. You will have XOR operation. In your XOR operation, if bits are same, it will give you 0. If bits are different, it will give you 1. So always start with 1. You if zeros are there, you have to let us suppose, now in this case I have the first bit as 1. Now if the first bit is 0, what shall I do? You are telling that you have to start with 1. So if the first bit is 0, what shall I do? What shall I do means, in place of dividing with the given divisor, you divide with all zeros in the keep all zeros in the divisor and divide with that. Now I'll show you how to divide that. Now let us take in this case. So the first case I have 1, so I am dividing 1 1 0 0 1. Now what I have, 0 here, 0 here, 1 here, 0 here, and here I have 0. Now what shall I do? What shall I do is, now what I am doing is, so first bit I have to cut off. Now look at the second bit, look at the bit which is having it is 0. Now if it is 0, what I have to do? I have to do the XOR operation by all zeros. Now you look at, see, you have 4 bits only. So to replace that, we have bring down 1 bit. Now you'll have 5 bits, and now you perform XOR operation for this. Now if you perform XOR operation, this will be 0 1 0 0 0. Now again you cross this one, and again you bring your 1 down. Now it is first bit is 1. You have to perform the XOR operation with your given divisor, that is a 1 1 0 1. Now what you'll get, 0 1 0 0 0. Like that you have to perform all the division, and at the last, whatever you get the remainder, in that remainder the last 4 bits are to be replaced by this 4 zeros over here. Now let us see the division over here.